Hello and welcome to the presentation today. In the coming 20 minutes, I'm going to discuss our solar system. The definition of the solar system is that it is a collection of planets, moons, stars, asteroids, and meteoroids orbiting one huge burning star, which is our sun. And the largest objects are 8 planets, some of them compared with moons. For the simplifications, I have separated the solar system to 7 components. The first component is our sun, which is the center of our solar system. It is bonded to 8 planets orbiting it in different times, velocities, and distances from its axial rotation. The second component is the terrestrial planets, and the terrestrial planets are 4. In the first order is the planet Mercury, and the second order is Venus, and the third order is the planet Earth, and also the planet Mars in the fourth order. The third component of the solar system is the asteroid belt, and the asteroid belt is simply separating the terrestrial planet from the Jovian planets, and it contains small solar system bodies composed of rocky and metallic minerals and ice. The radius of these asteroids varies between 1 meter to several hundred kilometers, and the asteroid smaller than the 1 meter in diameter, called grain-sized meteoroids, or the micrometeoroids, and also the finer asteroids called the cosmic dust. As to show where the position of this asteroid belt, we have chosen this image to show the asteroid belt, which is surrounding the terrestrial planets and separating the terrestrial planet from the Jovian planet, which are the Jupiter, Saturn, Uranus, and Neptune. The fourth component of the solar system is the planets Jupiter and the planet Saturn. These two immense planets are composed of gases, helium and nitrogen. Jupiter has multiple rings of gases surrounding the core of the planet, and Saturn has multiple rings of meteoroids and asteroids surrounding the planets. These two planets do not have a solid surface, which means that they don't have the lithosphere, just like the terrestrial planets. The fifth component of the solar system is the two last planets of our solar system, which are the Uranus and also the Neptune. These two planets are composed of mainly of ice, which is H2O, and methane, and also ammonium. These components are there, and it is observable that there is also the element carbon, which is a source of the life, is also composing these planets. These two planets has also rings and also asteroid around them. The planets Uranus is its rotation is horizontal, and also the planet Neptune, they are also huge moons and solar system bodies orbiting the planet Neptune. The sixth component is the Kuiper belt or Kuiper cliff, and the Kuiper cliff is composes of several spherical clouds, and the first one is the resonance belt, which is trans-Neptunian objects orbiting the planet Neptune, and we have the classical belt, which is also called the Kuiper-Ono belt, orbiting beyond the resonance belt control, and the termination shock, which is also a cloud shape surrounding the solar system and being observed by the satellite Voyager 1 and Voyager 2 in 2012. The heliopause, it is a solar wind termination zone, which the solar wind, our solar wind cannot reach this area, and therefore it is supposed to be the interstellar space. And the hydrogen wall, it is composed of the gas hydrogen, and we have the bow shock, which is a plasma left by the sun as it's travel through the Milky Way galaxy. These spherical shaped clouds protecting the solar system from any outside intrusion of space objects. And the feature of the Kuiper belt, as shown here, is a birthplace for many comets traveling within our solar system, and like the asteroid belt, it's consisting of icy objects, and it's surrounding our solar system component and protecting it from any objects coming from outside the solar system. And the largest observed body is the Pluto. Pluto has been considered as the ninth planet of our solar system in 1930, but this idea has been rejected in 2006 because scientists believe that this planet or this solar body is not fulfilling the definition of the solar system planets. And the Pluto has also a moon. Its moon is bright and is called Charon. The Mech and Haumea solar bodies belongs to the belt, the classical belt, and they are also bright objects. And the largest known scattered disk in this area known is the Eris scatter disk. The seventh objects or components of our solar system is the Oort clouds, and the Oort clouds is the edge of our solar system, and it is spherical cloud of trillions of icy objects, and is thought to be the source for long period comets that are out of the gravitational effect of our sun. Now, the first written theories about the origin of our solar system is written by philosophers Descartes, Kant, and Laplace in 1796. They suggested the first scientific theory that explaining the origin of the solar system. They suppose that slowly spinning clouds of gas and dust cooled out and collapsed under the gravity. As it collapsed, so it spun faster and flattened along the spin axis. The following is a diagram shows the step where they suggested from gas spinning clouds to the planets in traveling in orbit around the sun. James Jeans in 1917 suggested a dualistic theory. He proposed that there are planets were produced by different mechanisms, and he proposed that a massive star passed by the sun, drawing tidal filament from it. These filaments gravitationally were unstable and broke up with the condensational processes of the protoplanets forming, and then the protoplanets retained in heliocentric orbits, and the proto-satellites formed at the first perihelion passage filament. Bundy and Hoyle, 1944, suggested that a cloud of materials moves relatively to a star at speed v, shown in this image, which was greater than the escape speed. And they suggested that the deflected interacting streams, such as in point G shown in this image, lose their component of velocity perpendicular to the original direction of the stream. This means that the residual speed can then be less than the escape speed. Larsen in 1989 suggested the gravitational effect of a massive trailing spiral arm, which is to add orbital angular moment at the point B and subtract it again in point Q. I will leave the article Origin of the Solar System in the description box for anyone curious to learn or read more about the origin of the solar system. The solar system movement is elliptical and in an orbit, which means that it is proposed that the solar system with its component moving in the space inside the Milky Way galaxy in an orbit, and this orbit has been measured to be between 225 to 250 million years that the solar system can complete one orbit. The following video clip shows the idea that the solar system and the components belong to the solar system is actually moving inside the Milky Way galaxy. Here it is shown the clouds around the solar system is also described in this presentation as a component number 6 and number 7. It's surrounding the solar system while it's moving in an orbit within the Milky Way galaxy. The orbits of the planets is never the same. It's never at same place and time, and also the distance. The following table shows the speed of the elements of the solar system. The Earth is orbiting or revolutes about its axis in a speed of 0.4 kilometers per 1 second. The Earth is around the Sun, is orbiting the Sun in a rotation speed of 29.6 kilometers, and the average all Milky Way planets are also moving in a speed of 19.2 kilometers per 1 second, and the Milky Way galaxy around its axis is also moving in a speed of 220 kilometers per 1 second, and the Milky Way galaxy relative to other galaxies in the universe is also moving in a speed of 960,000 kilometers per 1 second, and it is notable that this speed is 3 times bigger than the speed of light, which can mean also that we are going back, in fact, in our history or universal history. That will keep us also thinking about the huge speed that the galaxy moving on, and the explanations that Einstein has offered us. If any object in the universe moving faster than the speed of the light, it will retain back in its history. The other table I would like to present in this presentation is information about the known objects of the solar system. The solar system objects are shown here in this column, and the diameter of the objects are shown in this column, and we have the core percentage of the size of the planet shown in this column, and the composition of the planet's core is also shown in this column. The composition and the percentage of the core is important for each planet to give the planet ability to produce electromagnetism field around it and protecting the planet better from the sun storms intrusion. Well, anyone studying the universe and the solar system cannot jump over or spring over the rules or the mathematical relationships of Newton or the theory of general relativity or the special relativity theory of Albert Einstein. The equation of a field equation of Einstein has been presented in 1915, and the following video clip shows the texture of time, space, and distance being presented mathematically by Einstein and Grosmann in 1915. The idea of the time-space curvature has been presented and involved the three known axes x, y, z, and adding the axis of space and time, and relatively to also the distance anomaly. The gravity is curvature and or texture of time and space, and the matter and the energy result in curvature of space-time are also resulting in the energy between the universe objects. The relativity theory has offered many other dimensions, knowledge dimensions, just like the gravitational time dilation and the light curvature and the gravitational lensing phenomena, and we have the time dilation subject and the red shifts, which are the waves moving away from us, and the gravitational waves, which also been observed in the project called LIGO in 2015. I will leave the original paper of Einstein and Grosmann published in 1913 in the description box for anyone curious would like to learn how Einstein and Grosmann come up with the idea of the general relativity, and this idea of course substituted Newton's rules, which the Newton rules dominated the physics, the celestial physics from 1665 until 1915, more than 300 years. All scientists in the studying the physics and the cosmology they thought that the rules offered by Newton are the one and never can be changed. But Albert Einstein came with the idea that the gravity is light and nothing exists in the universe called the gravity, but this is the light that can substitute the gravity between and attract the and the objects of the universe and the solar system, of course, also been attracted by the light curvature system. Well, we have come to the conclusions for the subject of today, and the conclusions of today are three, and I would like to present it here in this essay-like presentation. I would like to admit that the conclusions presented in this presentation are my personal reflections to the subject of today. Therefore, you are welcome to send us your comments and your questions and to make discussions about the content of the presentation today, and also the conclusions presented in this essay-like presentation. Well, in 1664, an epidemic reached England, and it was the pest epidemic. Authorities sent people home from the work and also from the educational institutions at that time. And one of the students that been sent home was Isaac Newton, and he used his time sitting down in restriction to think about math and universe and the solar system. He has been restricted at home in his garden, just like we do nowadays because of the COVID-19. Isaac Newton noticed that an apple fell down from the apple tree toward the ground of the ground surface, and he didn't ask, of course, because he was a clever man. He didn't ask why the apple fell down to the ground, but he asked why the moon is not falling down and the other planets are not falling down to the sun, and the moon is not falling down to the earth. To convince himself, he made some calculations to show out that in reality the moon is in fact falling down toward the earth, and the gravitation attractions of the earth is keeping the moon orbiting around itself. He needed to draw a drawing showing the earth and also the moon orbiting the earth in an elliptical orbit. And this elliptical orbit has two poles, the apogee, where the moon is farthest away from the earth, and the perigee, where the moon is nearest to the earth surface. And he showed that the moon can move sideways out from the orbit of the sun, but at the same time is falling down, just like the apple from in the garden is falling down to the orbit again. And this technique or this mechanism repeatedly happen during the moon's motion or rotation around the Earth. To make some calculations, he needed the diameter of the elliptical orbit, and he needed the distance of the moon orbit around the Earth, and he need also the time duration where the moon takes to make a rotation, a complete rotation around the Earth. And this time nowadays has been measured to be 27 days, 7 hours, 43 minutes and 11.5 seconds. And this period of time has been translated to second. At the Newton's time, he didn't have this huge technology we have today, and he used the number 29 to calculate the orbiting time he needed in his calculation. He made some propositions to make the calculations, and he proposed that the x should represent the side away movement of the moon away from its orbit, and the f should represent the fall of the moon to its orbit, just like an apple fall toward the ground of his garden. And he made also a calculation to the resistance between these two movement, and an angle between them is the theta angle. Then he could, of course, calculate the amount of the motion of the moon side away in a second. In 1 second, he find out that it's about 1 kilometer in 1 second. And he also calculated the amount of fall of the moon back to the orbit of the Earth, and he find out it is around this number, which is around million parts of an kilometers, and it is very little distance, but the falls happen in fact to the orbit again. Thus, you could prove that there is a fall from the moon toward its orbit, toward the Earth, just like an apple fall from the apple tree down to its ground garden. The following calculations are my reflections to the calculation made by Newton, and I would like to calculate and also propose some parameters, which is the big X oppositing the distance of the moon side away from the orbit, and the normal forces, which is the forces oppositing the in direction, of course, the gravitational attraction of the Earth for the moon, and I need the mass of the moon and also the gravitational attraction of the moon surface. When I have these parameters, I can calculate the amount of the resistance and the amount of the forces used to bring the moon back to its orbit, and the amount of the forces that pushed away by the moon itself to push itself away from the orbit of rotation around the planet Earth. The magnitude of these two forces shown here, which is shows us that the falling down forces are about 400,000 times bigger than the sideways forces movement of the moon. And lastly, I would like to leave a copy of Newton's calculations in the description box for anyone who curious would like to learn and read how Newton calculated the fall of the moon. For the second calculations, I've made this table, which represents the same calculation made by Newton and our additions to his calculations, and we find out we make the same calculation for the rest of the planets of the solar system, starting from the Mercury, Venus, Earth, Mars, Jupiter, and Saturn, Uranus, and Neptune. And we find out that the sideways movement of these planets are the same amount of the mean speed of velocity of the planets orbiting around the sun. So the amount of the fall in kilometer in second shown in this column here, and the fall forces needed to keep the planet around the sun shown here in this column, and also the forces needed for the planet to move side away from its orbit shown here, and also the magnitude of the F forces and the X forces needed to keep the planet orbiting around the sun. The following graph showing the ascending relation, or the descending relation between the fall of the planets in its orbit, starting from the planet Mercury to the farthest planet from the sun, which is the Neptune. That means that the fall to the orbit it is greater for the planet Mercury, and it is less amount of the forces being used by the sun to keep Neptune in its orbit and falling down to its orbit. The graph here shows the huge forces that being used by the sun to keep Jupiter planet in its orbit. That's because the great forces, the gravitational forces of the Saturn and also the Jupiter planets surface gravitational forces for the Jupiter. That also means that the Jupiter as a planet is also balancing the gravitational forces of the solar system. I will try to leave the calculation I made in this table and also these graphs in the description box, and I don't know in fact if YouTube accepts Excel file. If so, then I will leave this calculation in the description box. Well, in the conclusion number 3, I would like to present the parameter cosmic mass of the planet, because I believe that the planets in the solar system should not have a mass or a load inside the solar system. The mass has been measured and calculated from the density of the planets or the materials that making the density of the material that's composing the planet, and also the size of the planet. Such huge mass, the planet cannot move in the space, because we know all together that the planet is out in the space. There are no air to be lift the planet and travel and move around the sun. Therefore, I personally believe that the planet should have a load which is very, very little. To prove that, we should look at the formula presented by Newton, and we also can see that the distance between the planets is ascending or descending, comparable with the forces or the attraction force or the gravitation forces of the planets. When we are also looking at the acceleration, gravitational acceleration, we understand that is a relation between the velocity of the subject and also the time duration of the velocity. And we can also conclude that the velocity is of any objects moving is ascending with its gravitational forces and descending with the time expended to move the object. And also we should also look at the Einstein's equivalent mass equivalent equation, which is the give us the idea about the mass of the subject and the energy used to move the subject. When we look at these relations, we can also consider a parameter, we call it the cosmic mass, and it is the average velocity of the planet v divided by the distance from the sun surface to the planet, a little r. And then we have the equation called the cosmic mass, which is the velocity of the average velocity movement of the planet divided by the distance, or the planet's distance from the sun. If you have these equations, and we have also many other parameters, we can calculate the mass of the planet in the space. I've come to this table, where in this table we can find the planets in this column, and we can also see the actual mass of the planet measured by the density of the planet multiplied by the size of the planet, and we have the average velocity of the planet shown in this column. Then we can also have the distance from the sun for each planet, and we have calculated the cosmic mass of the planet in kilos, which you can also see it is very, very little amount, which is in micron and micron parts of a kilo. That is can be negotiable, and also give us an idea about the cosmic mass of the planet in the space. When we should use the mass equivalent equation of Einstein, we can also calculate the energy needed to move the planets in an orbit around the sun, and this is the numbers in joule per meter, and also in kilonewton per meter, which is again a huge amount of the forces that the sun used to keep all the planets in their orbit. The following also is a graph showing that the amount of the gravitational energy used by the sun is descending away from the sun. Now we have come to the end of our presentation today, and I would like to admit that the conclusions presented in this video presentation reflecting my understanding to the subject solar system, and therefore your comments and questions are more than welcomed to give us all together better understanding and discussion to the subject of today. Well, I would like to thank you for watching the presentation today, and my name is Sabah. I am engineer geologist, and my next lecture will deal with the geological timescale and the Earth evolution during the Eon Phanerozoic. Thanks again for watching, and take care.